going on, just keeping an eye on our winch, keeping an eye on all the everything, really, as we do. When we get near the surface, about 300 meters, that's about when Miles starts doing his nav checklist, 500 to 300 meters.
Okay.
And we kind of keep coming up more or less the same until we get to about 100 meters. That's when we start taking the stick out and just keeping an eye on our stuff even more, because we're going to be handing over to the deck pretty soon. So 50 meters, we'll hand over to the deck. At that time, once the deck has control and once the deck is cleared for recovery, like people are on the bridge and everyone's ready, then they'll take control of the winch, they'll start coming up. At that time, you'll do turn off your thrusters, which they're already off, great.
Yep.
You'll stow the tilt platform, you'll tilt the HD camera up, watching camera 5. Those are the most important ones. The next most important is turning your lights off. In the daytime, it doesn't really matter, but at nighttime, you kind of want to turn them off in the last 10 to 5 meters, just so that the deck can see them coming up.
Yep.
And then, yeah, you don't need to turn any of the other instruments off. Some people like to turn the sonars and the whatever off. You can leave them all on.
Okay.
Yeah? Is it better than turning it off with the, isn't it the same as turning it off with high voltage? It would do that if you turn it off there or with high voltage. Oh, okay. If you want. You can do that after too, right? Can you speed up to 20, please? Say again, Miles?
Talk to us, Miles.
Yeah, 21, 22 is good too. That might be a bit fast. Like 20 to 22. Well, that's good. Yeah, I think I can keep up with that.
Good.
Thanks to all our viewers tuned in with us, getting some really nice notes of people enjoying the dives.
So I can't hear you, Megan.
Interesting.
There you go. Now I can.
Just getting some really nice notes from viewers that they've enjoyed the dive. So
Oh, great.
Glad for that. Thanks for tuning in with us.
So once the tilt is up, you'll secure the tilt power so it doesn't do its thing on its own.
Yep.
Important to leave the crossbow and Paro on, regardless of whether you want to turn instruments and everything off. Leaving those two on helps me understand where I am relative to you. We'll lose USBL hits after 50 meters and above. So my navigation is entirely based off of where we were and the cameras. And I kind of remember where we were, looking at our headings and stuff and the delta depths. And if we move off this way or that way, I only get that from heading input.
Okay. Yeah.
So yeah, and when we get close to that, we can talk it over again. You don't need to remember all that, but in general, that's the overview. Yeah, I think now is probably a good time for this. So let's do that. Can you come full wide on Hercules, please?
Full wide.
Double extra super full wide.
Deluxe wide.
It's as wide as it gets.
So we've changed the cameras briefly, if you're watching online, over to a couple different views. We'll put them back so you can see the plankton shortly. But right now, if you're watching on channel 1, you're watching the backwards facing camera. So you're seeing Argus looking out at Hercules. On channel 2, Hercules looking out at Argus. And then on the quad in the lower left, you're seeing the...
So what I'm doing is I'm watching...
video. The main Zeus. Wait, Trevor, can I hear why you have the arm out right now? Oh, I wanted to hear why you have the arm out.
Okay.
You were like giving a great explanation.
Yeah.
Go.
About to start the arm explanation now.
All right.
So I'm going to lock out some joints.
Yeah, let's put it back. Yeah.
And let's see. Joint lock. Shoulder azimuth, shoulder elevation, and elbow are locked. So now you should be able to go with the end bits there. So remember, that's the halt. Don't worry about that button yet. This is just going to work with the rockers. So spin the wrist, and then grip lock is this button, and that's the jaws themselves.
Whoa.
So once you've got it in your hand, you move it around a little bit. Once you're comfortable, you hit that button to start it going. So you're right-handed?
Yeah.
Okay, so yeah. Yeah, exactly. Exactly, you got the hand positioning right. And while you're doing that, I'll keep an eye on the delta depth and stuff and tell you if you need to do any winching. So this hand, I find it easiest to grab kind of like this area.
Okay.
Because then you can kind of, I don't know, it totally depends on what your preference is, but being able to move this one up and down is helpful. So yeah, just play around with it, see what works. That'll be more relevant when you get to the other joints. So yeah, when you're ready, halt button is at the end there. And the jaws will immediately open.
How's it feel, Jake?
Weird.
Okay.
I don't know.
These jaws are really hard to learn with too for like that kind of up close stuff. The jaws are gangly. Could you halt that for a sec? And then put it down in the cradle. I might ask you to slow down slightly on the winch.
Okay.
You're doing 18 to 20. Let's do, let's see here. Let's do 17. It's going to bounce around, but 17 is fine. Yeah. Maybe slightly less. Maybe slightly faster.
Yeah, so the vehicle. Okay. Thanks, Una. Vehicles are ascending right now. We are wrapped up with this dive here at Palmyra. Do keep sending your questions in for the team. We've got a bit of time left as we're ascending up through the water column. It's a great chance to get your questions in and chat with our team. Interesting question.
I changed my mind. Maybe 16. Starting to slow down a little bit.
If Hercules or Argus move straight away from Nautilus on the surface, how far would they go before the weight of the tether wouldn't let them stay on the surface anymore? First part of that is that Argus would move zero distance away from the Nautilus before starting to descend because it doesn't have its own buoyancy. It is just like a heavy rock. You could think about it. So you couldn't kind of push your rock out onto the surface. It would immediately start to sag under the weight of both its own structure and the weight above. But
you could ask that question is like
Yeah.
how if you just paid out enough on the winch to keep Argus floating on the hovering on the surface.
Yeah.
How far could Herc pull it before it would try to swing back? I don't know.
Yeah, how much
I bet
force?
45 degrees, which is not very far.
Yeah.
That's, I don't know, 5-10 meters.
Yeah. Yeah, from the A-frame, that's not a huge distance.
Even that would be full stick ahead and not useful.
Yeah, and I mean, Hercules is only floating with about 30, 40 pounds of positive buoyancy, right? So it couldn't apply a lot of extra tether weight before it would start to push down. It's a good question. How much does the cable weigh? Do we know that? Anybody know that fun fact?
10,000 pounds.
Nice.
Really approximately.
Okay. Were you around for the installation? Did you go down to
I did
Sonata
not, no.
this year?
I did a tiny bit of shoreside support,
Mm-hmm.
but I did not involve myself in the installation.
Yeah, for longtime viewers of Nautilus, you'll notice some changes on deck. If you're looking at the deck cameras or you're looking straight down from aft camera when we're recovering, the cable drum, the 6/8 cable is no longer on a direct drive winch on deck. It is actually now in a different type of winch. That is, most of the components are down below the deck. So there was some major work done to Nautilus during this last off season to get a different type of winch, which better manages sort of an intermediate tension on the cable in between the force that's felt as the cable goes over the A-frame and down to the vehicles, which is impacted by the ship's heave and the wave height and the depth that the ROVs are at. And so in between that tension and the tension that actually goes onto the spooling drum, you can think about that like a spool of thread. Really good improvement. Certainly helps improve our capability for operations out here in large ocean basins where you get really big swell. If you did miss any of the dive today, our dives are available now on YouTube, hour by hour, full dive recording. So can't start just now rewatching it, but within the next day or two, the entire dive will be there so you could rewatch anything you missed.
Okay. Yeah. Yeah.
See, I try locking the jaws closed. And then you can let go of the thing. Oh yeah, you did. Yeah, perfect. Yep.
So we've got our Argus pilot and ROV intern Jake on the controller right now. Just trying out a few of the different controls for the Craft Predator arm. So Trev, I'm going to throw you the next question. How much does the ROV cable weigh per meter? Do you know that?
Well, no.
Okay. I was like, I don't know that number either.
But it's about 10,000 pounds. I'm going to do some metric and imperial mix-up here.
All right, let's do it.
It's about 10,000 pounds, and it's about 4,300 meters.
Okay.
There's an exercise for viewers at home.
Yes, let us know. Do your math.
It involves unit conversions, too. You can give me kilograms per meter or pounds per foot. Either way, it involves a unit conversion.
Yes, let us know. We'll just let you do that division. So 10,000 pounds, 4,300 meters. Divide that
Those
out.
are both approximate numbers, but they're order of magnitude estimate.
And question from a viewer, is the umbilical neutrally buoyant between the vehicles?
It is not. Oh, between the two vehicles?
Mm-hmm.
Medium neutrally buoyant.
What does that mean?
It means it's slightly positive or slightly negative, and I can't remember which. But we control the shape of it with floats and weights. So we have one weight a quarter of the way along, coming off Argus, and then a float in the middle, and another float 3/4 of the way along towards Herc. And that makes it make a nice lazy S shape called a catenary. Keeps the tether low and away from the bottom of Argus, and high and away from the top of Herc.
Awesome. I have all these questions. How much does the spool of cable cost? Cables are in the $250,000 ballpark. They can be a little more expensive depending on the features, and then installing them. So, we're in the ballpark of $500,000 with some of the cable changes happening on the vehicle.
Roger that.
So if you're, that's what I just noticed, if you're like closing the jaw at a certain speed, then you lock it, it like stays at that speed.
That's right. So in order to have it locked halfway, that's like a real advanced maneuver. You got to feather it with your pointer finger there till it's just staying open, and then lock it at exactly that amount of depression on the jaw lock button. These are the easiest jaws to halt halfway because they're a little bit more sticky. But it's not trivial to lock them halfway. It locks the amount of force you're applying versus the absolute position.
And Trevor, is that there's no unwind necessary for the wrist, is there?
There's no unwind, you say?
Is there?
No,
or is there not?
No requirement for that. It's got a, it just rotates about the one
axis.
hydraulic rod. Yeah, so it can spin forever. All the electronics that it involved in position, what's the word I'm looking for? Position feedback, they're all contained before the rotation part, not after.
Okay.
All right, viewers did their math. It is just about a kilogram per meter. 10,000 pounds is about 4,500 kilograms. 4,500 kilograms across 4,300 meters, just a little bit more than a kilogram per meter. Well done. Well done with the math homework. Okay, Trevor, question circling back. Some people remember our conversation about selecting the different jaws that can go onto the arm. Could you talk a little bit about what all those options are? What do we have to choose
what's
from?
on the arm?
The jaws, like these are the coral cutter jaws. They remember our conversation about picking out the best one for the dive in advance, and
Yeah.
what are the menu of choices available to a scientist before they start the dive?
All right, we got 3 jaw choices.
Mm-hmm.
This is the first one because they're in view.
Okay,
You
tell
got a
us about
question?
them.
Okay.
Just listening to you.
All right.
He's just gonna wave them around while we talk about them.
Yeah, these are the coral cutters. They're long and gangly and snaggly, but they have 2 blades on them, one on each side. They act kind of as scissors. And then the yellow-looking bits, that's Tygon tube, and that soft pinches the coral. So the slicer at the bottom pinches it off the live coral, and the yellow part soft squeezes them so as to not damage the sample. It holds it in position between those yellow tubes, and then you can put it in the box without squeezing the heck out of it between 2 metal surfaces. The other jaws, so the sacrifice for that is that they're long and gangly, but the benefit is obviously coral cutting and big rock samples. The gangliness and the tangliness is not good for grabbing hockey pucks, sampling, even the manipulator balls. The ones on the temp probe, for example, are not great with these.
Because the 2 fingers go inside? Basically 2 fingers on the outside, 2 fingers on the inside?
That's actually okay.
Okay.
But it's the fact that there's the long straight part with the blades and the Tygon tube.
Okay.
That does not sit well with the manipulator balls, or especially the hockey pucks. The next one on the menu is one we use the least amount, is, call them snaggletooth. So imagine the coral cutters, but without the coral cutter straight part. So those curvy jaws, the intermeshing jaws, are right against the edge of the wrist there.
Okay.
So it's a small version of
intermeshing
these.
meaning?
Intermeshing meaning the fingers go between themselves. So similar to
Yeah,
if
2
Jake were to
fingers
close
inside, 2
the-
fingers outside.
Yeah, if Jake were to close these right now, you'd see the curvy jaw tip part go inside the other curvy jaw tip part. So snaggletooth or intermeshing jaws are a smaller version of these, just without the coral cutter part.
Okay.
They're good for grabbing small rocks. They're good for grabbing manipulator balls. They're not good for hockey pucks, and they are only okay for grabbing soft, squishy things.
Okay.
And then the ones we normally run with are parallel jaws, which opening and closing, the flat jaws stay totally parallel. Those are really good for hockey pucks. They're really good for manip balls. They're really good for small rocks, small squishy things. They don't cut coral, and they don't open as wide as the snaggletooth or coral cutters. And that's them in a nutshell.
Fantastic.
Let me know when you think you're ready for another joint. Have you tried this one too? You got your favorite? You like this one?
Yeah.
Cool. If you're ready for another joint, let me know and I'll set it up.
Yeah, let's do it.
Okay. So to pass it off, you got to have it halted and put away in the little stow thing. And usually best practice is to have it halted with the jaws closed, just so if you're driving into something, then you're not going to get all tangly.
So science team, did you get a rundown of those jaws in that detail, or how did you decide which ones you wanted to go with? Or did Steve drive it with the coral sampling?
Come full wide, please, Wayne.
It was the coral sampling took precedence because we thought we could get enough rock samples with the core cutters. Nothing too big. I mean, we were kind of collecting rocks off that were free and easy to get, so we didn't have to do any pryings. We didn't need any sort of bigger arm to get them out. So that was our choice. Precedence for the coral cutting.
Nice. Hey, Miles.
Yeah, go ahead.
Question come in for you. They want to know what a navigator does during ascent, and how did you get to have this job?
During ascent, it's a lot of sort of organizing people and making sure the right systems are up and running for deck crew, and switching systems over from sort of bottom
speed up
mode to recovery mode.
What are the right systems for deck people?
Making sure the tanks are secure and enabling air for tuggers, letting Mark know things are happening.
That's good, thanks.
In a little bit, probably 700 meters, we'll start streaming forward to help Trevor sort of stay behind the ship. Making sure the captain knows that, we are going to recover. He always wants to be on the bridge during launches and recoveries. Changing cameras when video or I forget. Sort of multitasks there. Switching over from dead rec back to USBL solo. Just a bunch of sort of small stuff that all add up to make it happen.
Nice. And how did you get this job, Miles?
Right timing, proper timing. I was a lab manager, lab tech at Penn State for 7 years, and we were a contracting science group for Nautilus in the Gulf of Mexico. And I came on as one of the scientists and managed to sneak into operations.
Very nice. And if you want to learn more about Miles, click the team, click on his little face on the little button that has his regular sized face that is in a little button. I should clarify.
His little face.
His little face.
Miles is known for his little face.
Yeah. And you can read more about the position. You also, if you click the team, can click on the navigator button, which is up at the top. And there is a super cool video about navigation and a description of what the role is like and some of the different types of education pathways people have and training pathways people have followed to get to do this kind of work.
Yeah, the big one that we've been trying to reinforce with navigation is a strong geospatial background. I think historically it's been more of an engineering role, and that has mixed results.
Mm-hmm. Why is the geospatial element so important?
Well, I mean, the whole thing is wrapped around knowing, or at least sort of agreeing on where we are in the world.
Agreeing.
But, you know, we deal with new scientists every couple weeks, and they all have their own geospatial data that's in any number of file formats that need to be converted and switched over to fit with our systems, and sort of having a good fundamental knowledge of GIS and geospatial technology facilitates that.
Yeah, perfect answer. And in our staffing model, navigators also work really closely with the mapping team or stand mapping watches. And so they're acquiring new bathymetry on the seafloor, and much of that is often informing the dives that we're going to conduct either later in a season or within the same expedition, maybe even the next dive. That's what's going to happen next. After this dive, we have a bit of a mapping transit to the next site, then a mapping pass or two over the dive area that'll help select the dive targets. So we're doing the whole mode of our basic exploration model in the next series of 8 hours or so.
All right, ready for more? Okay, you want to do gauges first, and then we'll keep going?
Yeah, good question. Our ROV is constantly measuring salinity, temperature, pressure, etc. Team?
Yes.
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 What tool does that?
CTD.
What's that stand for?
Conductivity, temperature, depth.
Yeah. Gold star. Where's the CTD on the vehicle?
Front port side.
Mm-hmm.
That's it right now.
There it is.
Just to the left of the lasers.
Hello.
You can see the BE on there. That's their Bird Electronics.
Bert? Like Ernie and Bert?
Like Seabird.
Like Big Bird.
Like bird. I was like, that is a profiler, so it's collecting data continuously. It's not at just a set collection point. So that is really neat. In our data series, you end up with basically a vertical profiler. We don't do CTD casts off of this ship. Most ships, kind of the bread and butter for standard oceanography, is like
we don't do a rosette.
Yeah, we don't
definitely do CTDs off this boat.
Yeah, but not an independent deployment. Like profile down, bring back up, collect water sample, kind of like bread and butter standard oceanography.
But we do a profile.
We do. We profile with a robot.
We just don't collect water on that profile.
Yeah.
That device does not send any data up. Is that correct? It records it locally?
That device. You're going to have to be more specific.
The one we just saw, the CBT.
The SBE, that one is constantly sending data up. There's a constant stream.
Oh, okay.
Yes.
So
the one we deploy over the back for mapping is you got to download it.
Yeah. Gotta get it back.
Yes. Ideally.
That's the dream.
Although it tries to run away.
You got to watch out for those trees that float by.
Danger pants.
Yeah. That was terrifying.
Where was that?
Off of Vancouver, almost up to Alaska. That was DFO last year.
Oh. That'll happen, yeah.
Mm-hmm. All right, question reviewer. About 4 years ago, we experienced a visit from a sperm whale. We absolutely did. If you haven't seen the highlight, go look at it on Nautilus Live. Were any of us there when it happened? I was there. I was in the lounge, actually, and the question is, were we worried the whale might damage the ROV? One of the things that stuck with me from that entire encounter is how absolutely in control that whale was of the situation. You know, we paused and just held position in the water column, and the whale spent 22 minutes. You know, we've cut it down to a highlight clip that's on the website, but the whale spent 22 minutes circling Hercules and cruising underneath the Argus. And you know, you hear the team in there say like, oh, he's going to bump you, but I was not actually worried that it would bump us at all. Just an amazing display of behavior, so curious. Sperm whales use echolocation, a specific type of it called coda clicks, to ping their environment and get information back. And we don't collect sound from the ROVs. We're not recording like with a hydrophone because the ROV makes so much of its own noise, but I feel like you can just say that you know that thing was just like clicking at us over and over, and it was doing these kind of slow rolls one side to the other, looking straight on, and then going underneath and doing the slow rolls looking, you know, sort of like a dog tilts their head, you know, left and then right. It was awesome. It was such a cool encounter. But no, I didn't feel like it was an aggressive thing, like at any point it was just going to bump into us or ram us or anything. It was just a remarkable moment of getting to experience, you know, something else exploring us a little bit. I was actually jumping up and down on the couch. That's what I was doing at that moment when that started. We couldn't believe it. Okay, Trevor, do we have a sonar on the ROV? If so, what kind?
Can I jump back to that in just a sec? We're going to start more arm training here. So I got both your shoulder joints are now unlocked. That's the left and the right, as well as the up and the down. So, winch speed is good, gauges are good. Let's go front porch bubble again. Or also, you could go preset 4 and you get another perspective there. Mess you up a little bit here.
Okay.
Yeah. Yeah, go ahead. What was the craft combat? The 2.5 or 3 or whatever it was?
A little under 3.
Okay. Cool. Yeah, Megan, Herc has, let's say, 2 sonars. It's got a forward-facing low sonar. Sees really close, really well, right in the front of us. And then we got a 360 sonar mounted on the top of Herc. Kind of got some blind spots up close, but it sees up to, call it 100 meters out pretty well. Argus has 1 360 sonar. It has a side scan sonar. It has a sub-bottom profiler. I think that's all the sonars on Argus.
If you go in for echo sounders, does the ADCP count?
I guess it could, yeah, it could count. Upside down ADCP, Doppler. And I guess the altimeter is also a sonar.
Shouting at the seafloor. How far am I away?
How far am I away? How far am I away? How far am I away? Shut up.
Where are you, seafloor? Yeah. Yeah. Marco, Earth.
Oh, and then the USBLs.
What's that mean, Miles?
Ultra short baseline. It's basically the vehicles are yelling at the ship to say, I'm here, I'm here, And then we do some trigonometry, or the system does some trigonometry and determines a range and bearing to the vehicles. And that's how we keep track of them. Well, and then that's correlated with ship GPS and the IMU, and then we can figure out where they are.
What's an IMU?
It's what, inertial movement unit?
What's that mean?
No, I'm sorry, it's an MRU. It's a motion reference unit.
Yeah.
It's basically the accelerometer, a better version of the accelerometer in your phone, but it's keeping track of vessel orientation.
What are all the ways a vessel can move? Talk us through it with a pointy hand
Oh, there's
example.
There's yaw, pitch, and roll. And heave.
Heave is if you took your hands and lifted them straight up and down, so vertical from the floor to the ceiling. Pitch is take your two palms together and make them look like a boat. This is the easiest way to explain all of these motions. Pitch is your fingers going up relative to your wrists and going down relative to your wrists. So that rotational up-down on the forward-back axis. Pitch, heave. Roll is side to side, so moving kind of thumb to pinky, thumb to pinky. It's the side-to-side motion that a lot of people associate with, with boats. If you imagine a boat just kind of rocking back and forth in the ocean, typically people are thinking about roll. Yaw is a swiveling motion, so imagine the axis going in between your two hands together and moving your fingers left and your wrists right, or your fingers right and your wrists left. That's yaw.
Yeah, yaw is basically a heading change.
Yeah. Swivel. So yeah.
Nice and gentle.
So between your roll,
your
side to side, pitch, up and down,
Trip you
heave,
up.
straight up and down, and yaw, heading change, you get a combination of the true motion
I
of
need
the
to
ship.
readjust.
Yeah.
And what's the weather right now, Miles?
Clear.
Beautiful.
You're
Beautiful.
like, there's
Warm.
Too hot.
tropical.
Humid.
It's so nice. Trevor's outside of his temperature tolerance.
What's that?
You're too far south for your temperature tolerance.
I am.
And not far south enough.
Yeah. It's going to be really hard to reach it with a shoulder down.
Okay.
The trick will be bringing the shoulder way up. Yeah, that's going to work for you. Maybe even more. That's probably perfect.
So when we collect samples, we notice that we take screen captures of them. What else is logged? So as I mentioned earlier, all of our data is united by a universal time signature, UTC time. So that references the video. It references all of the
Nice.
sensor data that's collected. So things like the CTD's measurements of what's the salinity in the area, what's the temperature, how deep are we, how deep is
Let's see if you-
altitude of the vehicle
Can you
off
come
the
at it like this
seafloor.
now?
Okay. Let's try.
The dissolved oxygen. So all of those metadata parameters are all connected to the samples, and we have the ability to manually take screen captures from the video, which are just frames from the video, when we collect samples. So the data logger, one of the things the data logger is doing is taking those screen captures throughout the dive, and then it's a job for the science communication fellows actually to cull through all of those images, thousands of images from a dive, and select out the dive highlights that'll be used in photo albums online or in reference.
Definitely a mind bender, isn't it?
Yeah. Perspective is weird.
So when we get to 500 meters, I think we'll call it, or
Okay.
450 or something.
Like this question, why are a lot of the ROV pilots Canadian?
Because not every ROV pilot is Canadian, but
No.
every Canadian is an ROV pilot.
False. Don't lie to the viewers, Trevor.
I don't know why that is. It is a phenomenon.
It is a phenomenon here. OET contracts Ocean Dynamics and Josh Chernoff to be the ROV operations lead manager, or ROV operations manager for the trust. Josh has worked with us for a long time and has just a great working knowledge of scientific ROVs in the field, but also particularly our system and the fairly unique requests that we place on this system, and the fact that we bring so many new pieces of technology out to integrate throughout a system, that we really want this ROV to be used as a test platform for new samplers and sensors. That's a big ask of our ROV team, and takes somebody with experience understanding who the types of pilots are to staff for this. And also the fact that Nautilus is a teaching and learning environment. Every single expedition has a member of the ROV team who's maybe never been to sea before, but certainly has never been working with our system. Jake is our ROV engineering intern in this time. So, you know, one of the great things about having a consistent operations lead for the ROV team is just knowing people within the professional network and within Ocean Dynamics as a company that are a good fit for this type of mission. So Trevor works for Ocean Dynamics, and many of our contractors are sort of identified through Ocean Dynamics and then contracted through OET to come out and sail with us. So Bob Waters, who's not on this leg, but Bob works for OET as an organization proper, but that is the only...
Can I show you a challenge?
Sure.
Okay.
Aside from Josh, that's the only ROV pilots that are actually on staff with the trust sort of year-round, or Josh is contracted year-round.
So you can go tap the end vertically. Tap the end horizontally. And I don't know if you can get the total pointed in or not. Let's see. Yeah, I think you should point it this way. So all kind of three aspects. Up like this, and then down, and then around the side. And eventually where that challenge gets, which is actually extra hard, is if you can, it's kind of hard because you're all in close, but the dream is you can pivot the whole arm around the end effector. So you can leave the jaw tips right where they are. It's a lot easier with the parallels because they're more spatially correspondent, but you can leave the jaw there and rotate the whole arm about the jaw while keeping it just nearby there. And then you kind of rotate it down so it's horizontal. You can bring it around the side too, while keeping the jaw not in constant contact, but like within a couple inches of it. But the first step is just try to approach it in 3 different ways. I can see it's, I'm not very good at this one either, but in theory you can do it.
Well, I'm sure I'll struggle.
All right, Wayne, next question's for you. What are the green, red, and blue tapes on the arm? Why are they there? What are we using for?
We're using there to confirm that we have achieved a quality white balance. The ability for regular cameras to capture color at different depths of the ocean is very difficult. So what you need to do is you need to bring with you a reference piece of white material. In this case, there's also, just out of frame above the red tape, is a piece of white tape that we use to zero out our camera, or basically teach our camera what true white is at all the different depths that we dive at. So once we get on station on a dive, one of the first things we do is we use this manipulator arm, and you can just see it coming into frame now on sat feed 1. We'll manipulate that piece of white material into the center of the frame. We'll zoom in as much as we can with the camera to fill as much of the frame with that known white area, bring it into focus, and white balance the camera. And once we've done that, we pull out wide, and we can immediately see, because of those 3 pieces of tape, whether or not our white balance was successful. And they should look as they do now, which is the same as they would look at the surface with a regular camera.
Cat shark. Awesome. Great explanation. Thank you.
Did that cat shark follow us up from the bottom?
That's the first I saw it. I don't know.
Very subtle.
That's commitment, if so.
Do we have a pet shark now?
Pet cat.
Pet
Shark.
Ferdinand Magellan. Cat shark.
Sigmund Boyd. My parents' current dog is E.O. Wilson, but that's not funny.
That's not funny. That's just okay. My parents' current dog's name is Abby, like, which is a regular dog.
You know who E.O. Wilson is, right?
Yes, I do. I feel like we should do introductions in the last like 200 meters.
Yeah, 8? Yeah, weird. I've been looking at that. Do you not know?
Looks stingy.
Zappy. A little bit zappy.
I don't think so. I think it's the end of the rope.
What rope?
There's no rope over there.
Hope there's no rope over there.
On the porch.
Oh.
The ballast.
Oh, sorry, we're talking about different things.
Yeah. I'm talking to Rob, and he's offline, so...
Roger.
Mm. Yeah, you're talking about whatever's on the Niskins.
We are, yeah.
Yeah.
There are ropes on the Niskins.
No, it's definitely something stingy.
Ugh.
Tastes like burning.
So Rob, you want to talk to us a little bit about what this next feature that we're going to map and then dive on is?
Sure.
What's the next dive all about?
It's a true seamount this time. It's sitting just to the west of the Line Islands proper.
Okay.
And it's pretty interesting. It's
I'm gonna stop you. What's a true seamount mean? How do you mean that versus the others?
They separate it by 1,000 meters.
Okay.
Isolated 1,000. What we're on now is kind of more of a collection of more of a seamount chain.
Okay.
So this is more of an isolated seamount. And there are a bunch of small volcanoes around the edge of it. But then when you come up to the seamount itself, it looks like there's a couple of shelves on it that might be the GEO, the carbonate platform. And didn't really see any nice parasitic cones on this one. But we're missing about a 5-kilometer swath across the top of it. So we're hoping if we go through and map it, we might see a similar parasitic cone. But the direction we're probably going to come in from the southeast and head to the northwest. And at the base, there are a lot of small little ups and downs right there that may be a lot of interesting little targets for seamounts or for coral or in biology, as opposed to the nice little smooth uphills we had on these parasitic cones.
Okay. What's a geo?
A geo, it's a flat top seamount that was, when it was erupted, it was probably at or very near the surface. And over time, as the seafloor ages, it subsides. And as the seafloor is subsiding, the seamount kept getting deeper and deeper, and the coral reefs started forming around the edges. And then it continued, the coral reefs would keep growing, and at some point, it gets too deep that the coral reefs can't keep up. And so you kind of just have a flat top seamount that's surrounded or covered by a carbonate platform made of old corals.
Tell me more about seamount subsiding. How I think that's a really interesting concept for folks, that these mountains can actually sort of sink.
Well, the seafloor...
Not sort of sink, actually sink.
It's, you know, very well... I mean, the seafloor, when it's erupted, typically mid-ocean ridge will be about 2,500 meters. And over time it subsides due to the heat loss, because the seafloor is very warm when it's erupted. But over time it cools and it subsides, and it's very characteristic that it subsides at the square root of the age of the seafloor. So
interesting.
Yeah, which is a classic a heat flow exchange sort of relationship. And it does that until it's about maybe 55 or 65 million years old, and then it just kind of stays flat. So if the seamount is erupted on very young seafloor, it's going to subside very quickly. If it's erupted on older seafloor, it'll subside a little more slowly. And if it's erupted on really old seafloor, it probably won't subside at all, except for maybe the weight of the seamount kind of making the seafloor flex.
So that would be the seafloor and the seamount itself both losing heat in the youngest?
In the youngest, yeah, exactly. I mean, there is a little bit of phenomena when you do have a seamount or an eruption that occurs on older seafloor. It can, what we call, rejuvenate the regional seafloor. So it makes everything hotter. So it actually rises up, and then it will subside, rapidly too, initially.
How much are we talking about, like, change? We're talking about hundreds of meters?
We're talking
across?
thousands. If you want to, it's usually 350 meters square root of time. So at 100...
Square root as like 65 million. Square root of 65 million.
Yeah, exactly. I mean, so if it's a 25 million year old seafloor, so it's 5 times 350.
Okay.
So it's about 1.5 kilometers, almost 2 kilometers of drop in the first 25 years.
Wow. Whoa.
Does the weight of the of the volcano matter at all, or is it simply the square root of time?
No, this is just the seafloor, but the seamounts will have an effect on it. And what will happen if it's erupted on very young seafloor, what will often happen is it'll be locally compensated, so there's actually a mass that sits below that kind of supports the weight. But if it's erupted on older seafloor, the seamount can actually sit on the surface of the lithospheric plate and flex it down a little bit. So it's a little combination of things.
That's awesome. I think we've been trying to figure out we've been working with the Science Communication Fellows, and we bring them together for the workshop, and everybody learns about the science. And this year it came up, but it certainly came up last year as we were trying to talk about arch volcanism, to come up with something you could use like in a lesson plan. And we always go for food, right? What food would be the right texture to illustrate the fact that that plates can flex like this, that there's flexure in them? Because I think that's something that really surprises a lot of people. We just kind of think of like rocks, and they're incredibly rigid, and any rock that you've picked up and touched, that's the texture that you feel. But across these really big areas, and with the incredible mass that we're talking about, we're trying to think of like maybe Jello, like if you leave it out in the fridge and it gets that like kind of skin on it, that it's dried out a little bit, but otherwise not sure what would be the best illustration of that.
Yeah, also I think it was maybe like a lasagna noodle or something.
Okay. Like that hasn't been boiled all the way, but it's
Yeah.
been boiled a little bit?
Yeah. And so, I mean, but then you can actually cook it at different levels. So the most rigid, like the older seafloor, would be an uncooked.
Uncooked lasagna noodle? We're onto something here. Let's go down to the galley.
Well,
We'll
yeah.
work this out.
Yeah, lunch just started 3 minutes ago.
Lunch.
I was actually thinking like a Twizzler too.
Okay. How so?
I don't know. It has a little sort of a bendiness to it.
Yeah.
So if you hold it straight and put a weight in the middle.
I like that.
I like Twizzlers.
Yeah, we were trying to think of something, you know, like could you do, we have a great tech, you know, on nautiluslive.org. If you're watching, if you click the education tab and go into our free education resources, you can create your own login and they're totally free to use. We have a great module about tectonic plates. They use as frosting and graham crackers to jam together, and as you squish down the graham crackers, you can start to see you can create the different plate boundaries in that way and look at lava flow out, which is really fun. Plus you get to eat graham crackers and frosting, which is a big plus in my world. We're trying, someone had suggested like soggying graham crackers, and I was like, that sounds disgusting. So I really we were trying to think of if you could put something liquid underneath a layer of like slightly dried jello for arch volcanism, so that when you put a weight in it, you might actually break through and get the quotey fingers lava, the whatever your liquid or goo underneath would be. But lasagna noodles would do it, I think. You might have to like perforate the lasagna noodle to get the liquid out from underneath. Yeah, tomato sauce coming through.
But the thing about the arch volcanism that's kind of interesting is that when you push down, you actually flex up on the arch.
Yeah. Oh, there's one of those.
Yeah.
Note it. That was for the Amanda Netburn.
You know, the
Pelagothoria.
yeah.
Yeah, that distance away, you actually get that up push.
And it's actually that upward flexure which probably causes the melt that generates underneath there.
Explain that to me, that the flexure causes the melt.
Well, because at the base of the lithosphere, you're pretty much at the boundary between the temperature it takes to temperature and pressure to melt the mantle. And so anytime, there's another one.
Oh, cool.
Yeah, and so anytime you flex upward, you change the pressure situation. So you decompress it, which causes it to melt, the mantle to melt. And so with the bending, you probably have cracks in the lithosphere above, and you have melt there. So you have a nice little way to get melt to the surface. There's something similar that we see at subduction zones too, because as a plate goes down to subduction zone, you get upward flexure of the older seafloor. And we have these things they call petite spots.
Okay.
Which are, very, the chemistry says that they're from the base of the lithosphere in that area. And they're really small, but they, do make it up. So you see some along Japan. You see some down along the Tonga Kermadec. There's actually things we think, over near South America at that subduction zone as well.
So do they end up actually as little volcanic cones?
Yeah.
And then they just get scraped off and smashed in the subduction zone. So they're
I'm not sure if they get scraped off and smashed, but they'll probably get covered in more sediment and be part of the, whether they're below a décollement or get scraped off will depend on the age of the subduction zone.
Okay.
Or the age of the seafloor at the subduction zone.
That's really interesting. So you think of all of that being just the, oldest of the old sort of subducting, but then there are brand new little spots on it.
Yeah, these were just, within the last 10 years, they discovered these.
Petite spots.
Yeah.
Are there any up in the, like Juan de Fuca subduction area?
Probably not. They might be there,
Okay.
but the sedimentation rate is so high.